Hello everyone, welcome to CR Maths class. Now I am going to discuss location of roots related concept and problems, and see the conditions what they are given. Okay. Now location of roots of a quadratic equation under the given conditions. Location of real roots of the equation. If f of x is equal to ax square plus bx plus c is equal to 0, where discriminant is greater than 0, alpha, beta are roots, those are alpha less than beta. So with respect to take one real number k, the k is less than the roots, greater than the roots. So in that way we can discuss the conditions. If both the roots are greater than k, that means k value is small comparatively alpha and beta. Here observe that this is x-axis, this is y-axis. This is a curve that taken like this. If a greater than 0, a less than 0 means the curve will come downwards. This is y is equal to f of x. Where the curve intersect x-axis, those are the roots of the quadratic equation. Okay. Now these value, this is for suppose here x is equal to some t. This is we can write f of t. Y is equal to f of t. This is origin. Below the x-axis, this is negative. F of x function is negative. Above the x-axis, y is positive or not. At the time f of function is positive. See the first condition, a greater than 0. That means the curve is looking upward. So here see the k, and what is f of k value here? F of k value is greater than 0 because this is the point above the x-axis now. A greater than 0, f of k greater than 0. Then we get a into f of k greater than 0 only. Same like that, observe a is less than 0 and f of k is here. That means f of k is less than 0. A less than 0, f of k also less than 0. In this case, product of a and f of k, negative into negative, positive or not. Both the roots are greater than k. In that case, either a greater than 0 or less than 0, whatever may be. What is the condition? A into f of k greater than 0. Remember it. Both the roots are less than k. That means k is more comparatively alpha and beta. In this case, a is greater than 0. And observe here, f of k is here. F of k is positive. Now here, f of k is negative and a is less than 0. So both the curve, observe that a and f of k have same sign. Both are having same sign. Their product should be positive. A into f of k greater than 0. Okay. Both the roots are greater than k or less than k. Whatever may be, a into f of k value is positive. Students understood? Right. So I'm going to another condition. K lies between the roots. K lies between the roots. See here, this is the k. a greater than 0. This is k, a less than 0. If a greater than 0, then what is f of k here? F of k is less than 0. Here f of k is greater than 0. Then observe that a and f of k both are opposite sign. Both are opposite sign means their product is negative. Remember it. So the k is lies between the roots. Then what is the condition? A into f of k less than 0. Okay. 3 conditions completed. So next, for suppose I am taking 2 real numbers, k1, k2. See here, alpha, beta are roots between k1 and k2. So that's why outside k1, this is k2. Alpha, beta inside of k1, k2. In this case, observe that a is greater than 0. And here, f of k1 is positive, f of k2 also positive. A, f of k1, f of k2. All the terms are positive. Their product also positive only. Yes or no? What is the second case here? A is negative. Then see f of k1 negative, f of k2 also negative. A, f of k1, f of k2 negative. Their product is positive. A, f of k1, A, f of k2 both are positive. So finally what I am saying means the roots are lies between k1 and k2. In this case, a f of k1 greater than 0, a f of k2 greater than 0. Next, k1, k2 lies between the roots. Lies between the roots. In this case, what we get the condition? See, here is the k1, here is the k2. Then what about f of k1 and f of k2 below the x-axis? Those are negative or not? A is positive, f of k1 is negative. Positive into negative, negative. Here also same, negative. Understood? Go to the second case. If a less than 0, f of k1 and f of k2, those are in above x-axis. So f of k1, f of k2 positive, but a less than 0. In this case, a f of k1, a f of k2 value, what we get? Both less than 0 only. Previous case, both positive. Now here, negative. Okay, understood? Now, k1 less than alpha, less than k2, less than beta. So here, this is the k1, this is the k2. Here is alpha, here is the beta. A greater than 0. Then what is f of k1 student here? F of k1 positive, f of k2 negative. Okay. Here observe this case, f of k1 negative, f of k2 positive. Now observe that here a is less than 0. A into f of k1 greater than 0, but a into f of k2 less than 0 in both the cases, because a positive, f negative. When it is possible, both are positive. If a greater than 0, f of k1, a less than 0, f of k2. Okay. So overall, in both the cases, in both the cases, a into f of k1 positive, a into f of k2 is negative. Okay. So I'm going to another condition, right? These are the conditions completed. And observe here f of k1, f of k2 less than 0. Here one is positive, one is negative, one is negative, one is positive. Positive into negative, negative only now. So these are the figures and concept of location of the roots. Okay, right. Now I'm going to discuss the one problem. See this problem, what they given. The set of values of P for which 6 lies between the roots. 6 is lies between the roots. What is the A value here? A value is 1. It is greater than 6. Now the curve is like this. So no, this is x-axis. Now here is the K value, that is 6. So this is f of 6. Below the x-axis, this is negative or not? And A is positive. So their product, what will come, students? A into f of 6, what? Less than 0. Okay. Now substitute those values here. A means 1. F of 6 means this is, you have to think f of x. F of 6 means 36 plus 6 2s are 12. 12 into p minus 3 plus 9 less than 0. So calculate this. 36 plus 9, 45 plus 12p minus 36 less than 0. 12p, 45 minus 36 plus 9, send right hand side minus 9. P is less than minus 9 by 12. That means minus 3 by 4 or not. So P is less than minus 3 by 4. Therefore, P belongs to minus infinite comma minus 3 by 4. Minus 3 by 4. Okay. So which option correct, students? Second option. Read the question carefully. Both the roots of the equation are greater than minus 2, less than 4. All the values of m for which both the roots of the equations greater than minus 2, less than 4. So in this case, we can observe these conditions. That's why here f of minus 2, this is f of 4. In both the cases, both are positive. By observing the quadratic equation, a value is 1, it is greater than 0. Now product of a f of minus 2, a f of 4, both are positive. So f of x is given quadratic equation. Substitute those values here. So you will get the conditions after calculation. By observing the options, these two numbers are there. So finally, we get the answer minus 1 less than m less than 3. M belongs to minus 1 comma 3. Okay, which option correct? First option. Or otherwise, go to alternative method. Find the roots of the quadratic equation by using formula minus b plus r minus under root b square minus 4ac by 3. One is less than minus 2. Another one is greater than 4. So one of the root less than minus 2. Another root greater than 4. Use that condition. You will get one of the value is minus 1 less than m. Another value is m less than 3. By using both the cases, we get answer m value lies between minus 1 comma 3. Okay.